Let's look at the outer circle one last time. Remember, the outer circle is actually the unit circle. This time we're going to look at the one that's at 150 degrees, which is this point that's right there. So obviously you're not going to make yourself a right triangle that has 150 degrees in it. Nah, there's another way to do it. I mean, you could form yourself a right triangle right here and ignore the fact that you've got 150 degrees. You can just use the 30 degrees. That's one way to do it. But I think that we can do it even easier than that. As a matter of fact, all we need is those first 2 points that we got, and we can get the rest of them pretty easily. Okay, so here's the point that we just came up with, the square root of 3 over 2, comma 1/2 at the 30 degree mark. 30 degree mark is the same thing as that pi over 6 mark for radians. Okay, and let's say that I want the one that's at 150 degrees. 150 degrees is the same thing as 5 pi over 6, this one here. Well, look at the y-axis. Look at where this point is. Bam, bam, bam. There's a symmetry right there. We could just take this point and reflect it across the y-axis. When we reflect across the y-axis, the y-coordinate does not change, only the x-coordinate. It's got to be the same distance away, so it's going to be negative square root of 3 over 2, comma 1/2. And then we can extend that and do the same thing for the other coordinates. So for example, we just found square root of 2 over 2, comma square root of 2 over 2, which is at the 45 degree mark, which is the same thing as the pi over 4. And I can reflect that across the y-axis. When I reflect it across the y-axis, I should be able to get this point here. That's at the 135 degrees. In terms of radians, that is 3 pi over 4, 3/4, right? And so again, it's the x-coordinate that's going to be negative, but the y-coordinate will stay positive. Negative square root of 2 over 2, comma root 2 over 2. Okay, so let me tie this back into what we talked about before with the sine and cosine definitions. That remember that if I'm talking about 150 degrees right here, if I were to take the cosine of 150 degrees, I'm going to get negative square root of 3 over 2, it's the x-coordinate. If I were to take the sine of 150 degrees, I should get positive 1/2. Let's test those out in the calculator. Let's get a little bit of confidence here in the calculator. Okay, back over here. So we said we're going to take the cosine of negative, no, it wasn't negative, what am I thinking? Positive 150 degrees. Positive 150 degrees. It's negative 0.8660, and remember that's the same thing as negative square root of 3, arrow out, divided by 2. Remember, those two things are exactly the same. If I put in the sine, that's not sine, this one is. Oh, what the heck is that? It's like it confused it. The sine of 150 degrees, it should be positive 1/2, positive 0.5 still. Okay. All right, and then if I went back here, how would I find the tangent? How would I find the tangent of 150 degrees? The tangent should be the y-coordinate over the x-coordinate, and then I'd have to simplify it. And so that's the usefulness of the unit circle, is that I can use it to find these trig values pretty quickly without having to reference the calculator. Okay, but that still leaves out a whole bunch of other dots that are on that unit circle, and your task is just to apply that same kind of symmetry principle about reflecting points and stuff to finish off the rest of the unit circle. So you can find specifically the points at 60 degrees and the one that's at 120, and then all the stuff that's in the third quadrant and all the stuff that's in the fourth quadrant. All right, now before we end this lesson, I want you to definitely understand that these are not the only trig values that are on this unit circle. Every single one of them are. The only ones that we usually highlight are the ones that have these nice, neat numbers for them on the unit circle based on those special right triangles. So I'm going to do a little GeoGebra investigation. If you have access to a web browser, just go to geogebra.org, or perhaps you're on a device where you have the GeoGebra app. And I'm going to graph myself that unit circle. So I'm going to turn on my axes here. I don't need the grid. I'm just going to turn on the axis. And then I'm going to go to the calculator, and I'm going to type in my equation for the unit circle. And remember, that's x squared plus y squared is equal to 1. Not equal to 0, equal to 1. Enter. And there we go. There is our unit circle. Voila. So I'm going to get rid of that. Can kind of, and just zoom in. That's our unit circle right there. Okay. And so now what I'm going to do is I'm going to put in an angle measurement, because that's usually the sine, the cosine, tangent. All of that stuff is in terms of an angle measurement. So I'll go back over here to the geometry side this time. And let me draw in an angle. So coming from A to the center point B to this point on there. See, did it make a segment? I sure hope it did. Anyway, so I've got myself an angle, and I should be able to move this thing around. And I want to measure this angle here. Okay, so to measure that angle, got to go to More. Angle measurement, I select 3 points, A, B, and dang it, it did not preserve my point C that was right there. Okay, so let me back this thing up. I didn't have my extra segment on there. Okay, there we go. Now it's on there. And now I'll measure that angle. A, B, C. Bam. And you can see that it's at 19, what? Is that correct? What is this in? Okay, there it is. It must have been, it's obscured a little bit. Okay, so I have angle measurements in degrees there. I can either change that in the settings to, right here, settings. Under angles, I can go to either degrees or radians. Perhaps in pre-cal you'll talk about degrees, minutes, and seconds. Degrees, minutes, and seconds gives you a little bit more accuracy when you're talking about angle measurements. Let's go ahead and do it in terms of radians. I like those better anyway. Okay, so I'm going to move this thing around. Now remember that every single trig value is supposed to live on this unit circle. It's just that if I was at 30 degrees, which is the same thing as pi over 6, I know the exact coordinates for that one. But anything in between there, I may not know what those coordinates are. Okay? All right, but I have an equation that relates all of those numbers. It's the one that I put into the calculator there, right up here at the top. It's x squared plus y squared is equal to 1. That's how all of the numbers on the unit circle are related to each other. Okay, as a matter of fact, like, let me come back over here to the slideshow. And let's see, let me find a nice little spot here. We said, for example, that this coordinate was the square root of 3 over 2, comma, 1/2. This is my x coordinate, this is my y coordinate, that is cosine, and this is sine. Okay, let's put it into the equation of this circle, which is x squared plus y squared is supposed to equal to 1. So if I put in the square root of 3 over 2, square it, plus 1/2, and I square it, that should be equal to 1. So let's just work it out. Square root of 3 squared is 3, 2 squared is 4, plus 1/2 squared is 1/4, 3/4 and 1/4 definitely equals 1. All right, let me show you some other gorgeous mathematics, and that is the fact that x is the same thing as cosine, plus y is the same thing as sine. Whoops, let me make these thetas. I don't know why I made them x's. That should be equal to 1, right? This is called the Pythagorean identity. Nothing that you need to know for geometry, but it's definitely something that you will talk about. It'll be super important in pre-cal and in calculus. It relates sine and cosine together in that equation. All right, let's come back to GeoGebra here, where we had this circle, the unit circle. We have this angle measurement. Now, there is a little bit of a drawback here, and that is as soon as I get past 180 degrees or pi, it then starts to measure the bottom part, and I haven't figured out how I'm supposed to fix that. I think I can on the full web version, but not on this app version. Okay, anyway, so now what I want to do is I'm going to create a right triangle just like we did in the lesson here, okay? So to do that, I'm going to make a line. Let's come back over here. I'm going to make a line that goes to these 2 points, okay? And then I'm going to make a perpendicular line from that line to this point A that's right there. And then it makes that right triangle, okay? So there's the right triangle that we were able to get our coordinates from. And I'm only going to focus on one piece. I'm going to focus on just the height of that triangle, which is the y-coordinate. It's the only part that I care about just for the sake of this. And let me hide some stuff here. Let's hide this line. Okay, let me go back over there. So I put a little extra segment in there, so it makes that right triangle. Let's see if this right triangle sticks around whenever I move this. Oh, that's beautiful. It's beautiful. Beautiful. Okay, so remember, this is the y-coordinate. The length of this segment is the y-coordinate. The y-coordinate on the unit circle is the cosine of this angle that's being measured. Okay, so what I'm going to do is I'm going to create an ordered pair. I'm going to put an x-coordinate and a y-coordinate, an input and an output, and I'm going to graph it, and I'm going to see what happens. The input's going to be my angle measurement, the angle measurement that I'm measuring right here. And notice that that is measured right here. It's alpha. It says alpha is equal to angle through ABC. So that's going to be my x-coordinate, my input point. My output point is going to be the length of this segment from A to D. And I think that that's measured on here too. From A to D, it's right down here. It's J. It's J. So segment AD right now it's 0.8. Let me actually get the XY coordinates for this point. I think I can do that. Let's see. Caption, name, and value. There we go. So then we can see that that 0.8 that's there is the same thing as the 0.8 on the y coordinate there, right? Those two things are the same. So I'm going to make input output an ordered pair. Input's going to be the angle. I get that under the Greek menu. There's the alpha. Whoops, I forgot my parentheses. I need to go back to, I think it's the 1, 2, 3 menu. There's parentheses at the bottom. Go to the Greek alphabet, alpha, comma, and now for my y-coordinate I need to type J. J is the variable that that segment is stored under. So I'll go to the ABC menu and then type in J and then click enter over here. So it made myself an ordered pair. That's right there. And now it's a little bit hard to see if it does anything special. Actually, I'm going to collapse this menu so I can get a little bit better screen. You can see that it's doing some sort of shape here. I don't know what the heck that shape is, right? But a cool feature of this is that I can trace this point. So I'm going to go to the settings on point E, go to this ... and then show trace. Boom. I don't know if I can change the trace color. Maybe I can right here. Let's trace it in pink. Let's see if that happens. Okay. So let me trace it. Now, ordinarily, I should be able to see a lot more of this, but I'm locked into only this portion of it. Just by the limitation of this program, I can't measure this angle that's down there. This should be over 180 degrees or over pi radians, but it's not letting me. Okay, so let me show you what that is a part of. It is a part of this thing that we call the sine graph. Remember, this is the y-coordinate here. So if I type in here, if I type in, going back to the calculator, going back to the 1, 2, 3 menu, y is equal to, and then for the function part, I need the f of x, sine of x. X is the under the 1, 2, 3 for my input there. Now hit enter. Now let's come back here. Let's collapse this menu. And now let me move my angle measurement around. And you can see that if I were able to go down here and it measured the angle properly, it would continue on there like a roller coaster. Same thing with a negative angle measurement. And that's how we get it. This is how sine is defined. It's the y-coordinate on the unit circle. And this weird looking graph here, that's the sine wave. Sine waves are very, very important. We use them to model all kinds of things that oscillate. Oscillate means that it changes, like something changes. Like, for example, sound changes air pressure, and they're modeled by sine waves like this. Sine or cosine. Cosine, I can do the exact same thing to get the cosine graph, but it would just be the bottom of that segment. It'd be the x-coordinate of that segment. All right, that's it. That is a lot of trigonometry put together with circles and how those things tie together. We were able to define the equation of a circle in the coordinate plane as x minus h squared plus y minus k squared is equal to the radius squared. H and k is the center of the circle. And then we were able to see the usefulness and construct this thing called the unit circle, and we're using that unit circle to find the sine, the cosine, and the tangent of a whole bunch of different angle measurements based on the x-coordinate, which is the cosine, the y-coordinate, which is the sine, and y divided by x is the tangent.